Okay, so actually somebody stopped recording already. So let's go to the lesson. Okay, there are 16 of you here. Okay, let's try to start lesson as early as possible. Okay, you can see the screen. We are doing chapter 2 now. Okay, today I'll go slow. Okay, because quite a lot of things to do for. Okay, I will try to cover first point first. State the properties of a spherical triangle. And then the other one, maybe I'll do it tomorrow, okay, during the class time. Okay, so let's start now. The lesson is recorded. So the first point is actually introduce what is spherical triangle, then what are the properties, and then follow up with one example. And actually, we are going to use the Napier's rule to solve this triangle. Okay, right? So, introduction. This is something I'm not sure is required. I think spherical trigonometry is concerned with the sphere and the sphere triangle, spherical triangle. A sphere is a figure such that all points on the surface are equidistant from a certain point called the center. Okay, a straight line drawn from the center of the sphere to the surface is called radius, and a straight line through the center and the terminal point both ways by the surface are called diameter. So we know that there's the radius. There are a few things that let me point out there. There are a few things. One of them is the center of the sphere. Okay, there is a center of the sphere. There is a radius from the center to the surface of a sphere, and then a straight line joining the point, the center, and 2 points opposite to the surface is called diameter. So I think let's look at the diagram. Before I look at the diagram, I think let's see any message so far. Okay, no, not really message here. So first, we are going to introduce the great circle and small circle. So when you cut a plane across a sphere, then you usually get a circle. Okay, the intersection of two surfaces is a circle. Okay, you cut. So for example, there are many circles here. So when you cut the plane, you get, oh, this is a circle here. Okay, this intersection is a circle. Okay, what happened? So circle, right? In this case, some circle pass through the center of the Earth, and that we call it a great circle. So a great circle is a circle pass through the center of the Earth. So example, a great circle. This is a great circle. For example, a great circle at the equator. There's a red one, also a great circle. So a great circle can be anywhere as long as a big circle pass through the center of the Earth. And then there are other circle. We call it small circle, right? Small circle like So this one are small circle here. The other one are also small circle, right? As indicated in the diagram. And for our interests, we are always interested in great circle. Now for us, we are going to more focus on great circle because great circle is easier to calculation because the center of the great circle is always the center of the Earth. Okay, so this is talk about great circle. Okay, our focus is always on great circle. Now we're going to talk about spherical triangle. Okay, spherical triangle. What is a spherical triangle? The spherical triangle is portion of the surface of the sphere formed by three great circles. Arc of three great circles. So for example, what you can see is a spherical triangle on the diagram. So there are three great circles there. Let me draw for you. So this is one great circle. Okay, just one great circle here. Okay, so one great circle. So what you are actually taking is actually this portion of great circle. So then what you do is achieve this portion of great circle here. Okay, so they form a part of a spherical triangle. All right. Then you have another great circle passing through the center of the Earth there. So, for example, this one is a great circle. So you must have a great circle first. Then you see this portion of the great circle, this portion of arc here, form another side of triangle. Okay. Then another great circle. Let me try to use another color here. So another great circle is actually this one now. Okay, this one a bit difficult to draw because yeah, this is another one. Okay, a big circle until we get this one. So now we got a big circle here. So these three arcs form a triangle. Okay, these three arcs form a triangle. So this is called a spherical triangle. Okay, spherical triangle. And so a triangle must have three sides, right? The only thing is these three sides now is not straight line. Okay, it's not straight line now. Is three arc of a great circle, right? Meaning that this thing is not straight line anymore, right? This triangle has no straight line, okay? So spherical triangle, the three sides, when you draw it, are not straight line. So it's three parts of great circle here. Then over there, then of course the triangle got angle there. So if one of angle is a right angle, then we call it right angle spherical triangle, right? If one of the angle is right angle, okay. If one of the angle is right angle, then you call it right angle spherical triangle. So right angle spherical triangle is a term Doesn't mean that all the angle must be right angle. Doesn't mean that it must have right angle, but it happens to have a right angle triangle, spherical triangle, then you call it right angle triangle. Now, if one of the angle is 90 degrees. Okay, and how about if one of the side is 90 degrees? I will explain to you why talk about one of the side is 90 degrees, because the side now, how come the side is 90 degrees? I talk about this later on. How come the side now is 90 degrees now? Meaning, okay, I'll explain to you later. And this, in this case, we say that this is a quadrantal spherical triangle. Okay, if one side is 90 degrees, I will talk about this later. And then oblique spherical triangle. If you don't have any 90 degree inside a triangle, right, or side here, oblique here means, so when we say oblique means there no 90 degree there. Okay, so this is some introduction here. Okay, so some main properties of a spherical triangle. The sum of the triangle is greater than 180 and less than 540. Okay, number first point. Why is it so? So let's recall the plane triangle. If you have plane triangle, then the three sides are straight line. A, B, C, right? This straight line, plane triangle. Okay, so you got, of course, you get angle A, you get angle B, okay, angle A, angle B, angle C, right? So if for a plane triangle, we know angle A plus angle B plus angle C, all together is 180. Okay, for a spherical triangle, this is not so now. Okay, spherical triangle. Yeah, three sides again. Yeah, A, B, C. Okay, the three sides are up now. Okay, so the angle A, angle B, angle C there, same. But now the angle A plus angle B plus angle C, the sum is definitely less than greater than 180 now. Can be greater than 180 now. So greater than 180, huh? And less than 540, the most 540. Okay, so how is it that you have an angle, three side, three angle triangle greater than 180? Of course, you can measure it. Okay, and the three angle add together is less than 540. Okay, for the spherical triangle. Okay, so let's see. I can explain this the angle. Okay, let me maybe go to another side here. Okay, just try to draw a diagram here. You have a sphere. So this is the north pole, this is south pole. So you can actually form an arc and then the angle. So you can, okay, this is part of a great circle here. Remember, spherical triangle come from great circle here. So maybe I try to draw a great circle, pass through the North Pole and South Pole. Okay, so great circle always a big circle. Center at okay, this one spherical triangle. So you can take part of it, all right, part of it, and then form a triangle. So you can form a triangle here for part of it, okay. Part of the circle, then for the center of the earth here, and then you get this one part of the triangle, then you get another triangle arc here. Let's say great circle, not necessarily pass through the North Pole and South Pole, right? As long as it covers the center of the earth, it passes through the center of the earth, great circle, and then you get another side here. Okay, let me see. Okay, not necessarily the this can somewhere here you stop here, and then you get another great circle. Okay, great circle. Not necessarily pass the North Pole and South Pole, but it's contain the center of the earth. Say it's another great circle. So then you can actually get this one, let's say from here to here. Because you get three angles now, okay? So this three angle, this is called angle. Let's say this A, label the point B and C. So this angle C, this angle A, this angle B, right? Add together, the most is A plus B plus C. The most is 540. The minimum is 180. Okay, it will be greater than 180. So this is one result for a spherical triangle. Okay, then this is 1 point. Okay, now the second point, the side are expressed in degree, minute, and second. So second point here. What does it mean by the side expressed in degree, minute, and second? Okay, so how do you measure the side of a spherical triangle? We measure a triangle basically from the center of the earth. Okay, so for example, see any question here. So I'm going to give you another diagram again. Okay, so this is a sphere here again. I'm going to do a sphere again. So, and then, okay, just take for example, this is the center of the earth here, North Pole and South Pole. You draw a big circle, let's say from here. Okay, you draw a big circle, let's say you call a big circle. and you travel along the big circle, say from this point to this point. Okay, this A, this B. So what is the distance between A and B now? You can measure from the center of the Earth. Okay, what is this angle? Let's say this angle is 30 degrees. Then the angle is 30 degrees. Then this distance AB, distance AB, length of AB now. Instead of measure in kilometer, we use it 30 degrees. Okay, we write 30 degrees is the distance between A and B. So by measuring the angle from the center of the Earth, okay, by using this, we can find the length of AB. Okay, say that suppose you have another point C here. Okay, so let's say C is somewhere here, and another point. So this C here, and then this is equator. Now let's say this equator. So I can get equator here, a point on equator. Okay, so if the point equator, let's say this one also is here. So then what is angle from here to here? We don't know lah. Let's say this is say theta now is 60, and then you move down the below the south pole, toward the south pole, and then you have another angle. Let's say this one is 15. Okay, from the equator to West C now. So what is actually AC now? Okay, A to C. Okay, so distance, length of AC. You can measure the angle by adding up the angle here. A to the equator. Okay, A to the equator is 60 degrees. Then equator to the point C is 15 degrees. So this is 75 degrees. Okay. So what is the largest length you can find from one point of the Earth to another point if you measure the distance? Okay. So the largest length is actually 360. Okay, 360. Okay, this diagram will show you a bit here how to get largest length 360. So I have this diagram here on the side here. So for example, I have this diagram, the north to south here. So let me use this diagram here. Okay, so okay, north to south here. So what is the angle? What is the length of this thing? So from north to south, right? Because this angle is 90 degrees. So you can see that, okay, so this is 90 degrees here now. Okay, this is 90 degrees. North to south is 180 degrees, right? So this is one part of the great circle. So this is one length. So side is one part of the great circle. Is 180 degrees, like I said, right down there, right? So then you get another side of the great circle. Let's say another way. Okay, so another side of the great circle you can get from here. Part of this. okay, part of this one, and then great circle here. Okay, what is the distance from the South Pole to the equator again? 90 degree. Right? 90 degree. And then you draw another great circle again. So the triangle, right? So I have actually let's draw another triangle because I got mixed up here. So this one is not a good triangle here. So I have not a good triangle here. This one actually I have one here. Okay, this one is actually 180 degrees from north to south, and then another green one is 90 degrees, and then you have another blue one now. Let's say blue one. Okay, the orange one. Okay, orange one here. This one another 90 degree, right? This one also 90 degree. So the total length is at most 360 degree. Okay, the sum of three sides. The sum of any three sides at most 360 degree, right? The sum of three sides at most 360 degree. Now, also property of any triangle. The sum of two sides always greater than the third side. Okay. So for example, if this is, let's say this is 3 nautical miles, or this generally is true, right? Let's say this is 3 nautical miles, and this is 5 nautical miles. Okay. Then let's say this is 7 nautical miles. So we sum up this one. Okay, AB plus AC must be greater than at the third side. AB plus BC, sorry. AB plus BC must be greater than AC. Okay, for example, 3 plus 5 generally considered triangle. 3 plus 5 must be greater than 7, right? Okay. Same thing for spherical triangle. Let's say this is when you measure the distance, let's say AB is 35 degree. Okay, you measure the distance in terms of degree now, and ABC is 30 degree. Let's say this is so the sum of is when you draw a spherical triangle, right? The most may be 100 degree. So know that AB, the length of AB, the length of BC is 105 now, definitely greater than AC. Okay, so this is 2 point, and the sum of 3 sides, the most 360 degree. Okay, another thing you get equal side must have equal angle, which is quite common. I think everyone know here. If two sides have the same length, then angle must be the same. Okay, if two sides have the same length, the opposite angle must be the same here. So how about if the two sides are not equal? The angle are not equal also. Okay, the greater the length, the greater the angle, opposite angle, right? The greater angle is opposite on the greater side. Okay, if you have a big side, okay, if you have a this for any triangle as well. Okay, so if you have a big, so for example, this is 100. That means this angle is the largest angle. Compare all the by comparing all the sides, right? The bigger sides got bigger angle, okay, opposite angle. So this is some introduction, okay, to the spherical triangle, property of spherical triangle. Okay, so now I'm going to introduce to use how to for right angle spherical triangle. Right? So this is how to calculate the side and angle for right angle triangle. Right angle spherical triangle, right? How do you do that? So I have draw to you on the left hand side a spherical triangle where one of the angles is right angle. So this is one of the right angles. Yep. So this is right angle. Okay. So we have a method to calculate the right angle triangle, spherical triangle. As long as it's a right angle triangle, you can do this calculation called the Napier's rule. Okay. Before we talk about Napier's rule, let me see how do we draw the Napier's view. Okay. Napier's view. Okay. So let me introduce to you Napier's view. Okay, we have a right angle triangle. The triangle have three angle A, B, C. Okay, so this angle A, angle B, angle C, and then the side A, B, C. Opposite angle C is the side C, right? Opposite angle A is the side A, and so on. So we are going to do something called the Napier's view. So I'm going to first, how do you trace the triangle first? Okay. Trace the triangle crosswise. So trace triangle clockwise. So clockwise means follow the clock direction. So you can see the way the clock direction is always this way, right? Clockwise. Okay, so there are, you can see that there are the direction change, right? Clockwise. So what we do is actually trace the direction. Okay, so the direction of is actually this is direction here. So first, the first direction is go into the right angle triangle because the focus on right angle triangle. So there's a right angle triangle here. So you start from BC. BC is side A, right? So you go to C first. So this is side A. Then it encounter angle C, which is 90 degree. Then it move the side A, side B now. Okay, so actually, okay, this one side B. Okay, then, okay, go into side angle C, leave angle C, then go into angle A, then go into angle B, this side C. So you trace the triangle in this way. Okay, then you draw the Napier's view. Okay, Napier views is something while you do like this. So Napier's view. So you have divide the circle into half, and then divide the upper half into two parts. Divide the lower half into three parts. So actually, it look like a turtle, okay, something like a turtle head. Alright. So what you do is write the center 90 degree at the top left, top corner, angle C. Okay. Then you move. See how you view in this way, from the top left. See how to actually this one go in, right? Go into angle C. So that is why you put the side A here. Okay, go on the side A here, right? Then the C has already the angle there already. Then move the next one is the angle B now. So this one, you go to angle B. Okay, so this is angle B here. So B here. Then you hit the angle A. Okay, the side B first. Okay, from side A to side B, then hit the angle A now. So the next thing you can encounter is angle A. Okay, angle A is this one. Right, angle A. Then from angle A, you move side. So you actually move to the side C here. And then from the side C, you move to the angle B. Okay, move angle B here. So this angle B. So this angle B now. So we complete the views. Okay, this is how you complete the view, right? So I start out with the A. Use the color here to show you. I start out with A here, and then go to B. The C is at the center. Then go to angle A. Then go to side C. Then go to angle B again. And then after completing a view, we're going to put a symbol here called com. Okay, this is after what I explained to you. Okay, com. So write com here. So this is called the Napier's view. Okay, Napier's view. What is it all about here? Because this is a right angle spherical triangle. Okay, so the rule of Napier's view is okay. I go and name them according to what you have. Okay, there's a first one is a sine of the middle part. So through here, sine of middle part is a product of cosine of the opposite. So what does that mean? Sine of middle part is product of the opposite. So take for example, okay, take for example. So I'm going to use this, okay. I use C as a middle part first. So let's say I call this middle part here. This is a middle part, okay, middle part here. And then the opposite, okay, so there's a middle part here. Always have a middle part here, okay, the middle part. Then where is opposite of middle part? You can see that opposite of middle part is actually this one and this one. They are called opposite. So basically, this is the middle part here. You can pick anywhere to be a middle part. So this is the middle part here. So these two will be opposite. So knowing what is the middle part and what is opposite here. Okay, so this opposite here. Okay, so what does it mean now? It means that sine of middle part is an opposite product of cosine opposite. Okay, sine of middle part is a product of cosine opposite. The only thing we have to bear in mind that because of the word com there, anything below the half circle, you must put in a com. Okay, anything below half circle, you must put in a com. That means that sine of a com C. So that means that, for example, if I want to write this way, that means that sine of com C. Okay, sine of com C. Sine of small side, sine of com C. So this is a small side, side here. Okay, sine of com C. Small letter. Okay, small letter. Side. Sine of com C is product of cosine of opposite. That means cosine opposite is A. Cosine of B. So you have a sine of com C here. And product of A and B. So this one I'm going to say that this is A here. And then this is a B here. So sine of com C is called product A. What does it mean, a com C? Com C means complement of C. So the com C meaning, com C in this case, the meaning of com C is, yeah, com C, the meaning of com C is actually, okay, com C means side C, a small c here, because C angle here now is actually 90 minus C. Okay, come here. Anything below the lower part of the wheel, you need to apply the com. I'll show you later on, okay, how to apply this one. Okay, so this is about the middle part and the opposite, okay, about middle part and opposite. There's another rule, sine of a middle part, product of tangent of adjacent. So if I use the same middle part here, then the two things next to it is called adjacent now. So this thing is called adjacent now. Okay, these two are called adjacent now. Okay, beside this, they are called adjacent. In this case, what is the second statement say now? So remember, everything below the lower views, you must put a com. So the second part of the statement is actually sine of C again. Okay, so sine of com C now. So I go like sine of com C. is equal to what? Product of tangent of adjacent. So I have product of tangent of adjacent now. So let me put in color here. Adjacent. Tangent now. Let's just have a cosine. Now is tangent. So that means that I put in tangent now. So you get tangent so get tangent here. Because it's in the lower half now, the adjacent side one of them is A, one of them B, right? So come A. Then tangent of com B. Okay, tangent of com A. So no space here. Let me write somewhere else. So I have this right here. Sine of com C equal to tangent of com A tangent com B. Okay, so you must have, because in the lower half A and B angle are in the lower half, you have to put a com there. The com of whatever is 90 minus the angle here. So this is a rule we can apply. Okay, so I repeat again the two rules. Okay, we'll see that. Okay, the first thing is always put in the top right the angle C 90 degree. Okay, 90 degree. Put on the top right here 90 degree. So this 90 degree, right? Put it on the top here. Okay, then you go from clockwise. You get this. How to get into 90 degree? So this one is, we know is angle A, right? So that's why go into A and leave. Okay, this is where the one here. Okay, fill in this one, 1A. Then this is B. Okay, this is B here. So from 1, 2, okay, so this is actually 1 here, 2 here. Then you encounter angle A, so this 3 here. Okay, this is A now. Okay, angle A. So okay, 1 and 2. Then you angle A now, so that's why you get angle A here. So this one, let me put in color here. So A. Then next you move, continue to trace. Is 3 now. So C. Then you move angle B now. So this will be here. Okay, curve complete a view and you put a com in the lower part of the wheel. So this is actually one of the most difficult part of setting up the Napier's wheel. And as I say that in the formula, there are middle part and opposite part, and the middle part and the adjacent part. So how do you figure out the angle on the side based on this Napier's view, right? Actually based on this Napier's view here. So let's do example 1. So actually you draw a spherical triangle first. Okay, one of the angle must be right angle, okay? So you might make sure that you have right angle. If they don't have right angle, it's different story already. Okay, right angle. Okay, then you draw the according to the where is right angle. From there you can draw Napier's view, and then you see which are the things you know, which are the things you don't know. You find the unknown part. Okay, so what you do is use the known part. The given known part, you know the answer, then you find the unknown part. Okay, I don't like this one, so unknown part, I think I use this one. Okay, use the two given known part to find the unknown part. So that means that usually what we do is usually put it in the middle. So usually you know the unknown part, you want to find the unknown part there, you try to put it in the middle. Okay, so you try to put it in the middle. As middle part. As far as possible, try to middle. Okay, put this, the unknown part I want to find, try to put it in the middle part. Okay, then you can find the use the two given part, you know. Okay, hence you can solve the remaining whatever you know. Okay, using the connecting the unknown. So the last example I'm going to show you is a right angle triangle. Now I'm using this as a start. Okay, this is the beginning of the start. Also show you how to use the Napier's rule, and then tomorrow I'll continue example 2, right? Example 1 is enough already. So it's a right angle triangle, spherical triangle, PQR. So where is a 90 degree angle Q? So this is 90 degree, right? So we can draw a PQR here. So let me draw there are many ways to draw. So let's say I want to draw this 90 degree here. I mean this angle is Q here. There's PQR, right? So let's try to say this is P here. And this is angle R. Okay, so Q is 90 degree, which is good. Settle. Angle P is 45 degree. So let's say this big angle here. Use capital letter to angle. So this 45 degree. Settle. And side R, where is R? R is opposite angle R, right? This is side R here. It's 60 degree. Okay, so all this information are given to you now. So find side P and R, angle R. So I want to find out what is this P here, means this is small p. And the angle R. Okay, so let's try to draw the Napier's view. So Napier's view is over like that. So you have a point circle, top divided into 2 parts, bottom divided into 3 parts with a comb inside there. So we'll draw it, it will look like something like this. Okay, 3 parts. This comb there. So you know that 90 degrees is at Q, okay? 90 degrees is Q here. So you put a Q on top there. Then you do it clockwise, right? How to get on the Q, right? So first thing is how to get the Q is actually from here to here, right? So what is that? There's 60 degrees, right? So this is actually R here, small letter R here. This is R here, 60 degree. Okay, this one you know. Then afterward, go into Q now. Then you need next one is actually from here to here. Is let me use the blue color one. So you actually go here in the clockwise. So this is actually P, right? We don't know what is P. We're going to find out what is P here. So let's use a small letter here because this side here is a small P. So you write carefully. After P, we encounter the angle R. So this angle R here now. Okay. After angle R, we will continue to move. This is what now? Angle Q. No, not angle Q, it's side Q. Then afterward, encounter the angle P. Okay, P here, this is 45 degrees. Okay, so what we want to find? One of them is angle R, one of them is angle P. No, not P, right? Side P. So you look at what are the things you can find here. So obviously, let's find angle R first. Why is it angle R here? So let me use a color here. So this is middle part here, the middle part. Okay, and then two opposite part. Right, so you can find that. Okay, that's why I always the unknown. Okay, because you want to find unknown, right? Because you find okay, this unknown are unknown, right? So use it as middle part, and happen that the opposite you all know. Okay, because there's no point to find P at the moment. P is at the moment you don't know because you don't know what is opposite of P. Okay, because Q you don't know. Okay, so therefore you can actually use R first. R opposite is 60 and 45. So we use a formula. Okay, sine of the middle here. So formula, let me copy the sine of middle first to show you. Okay, so this one, let me copy this thing. Okay, sine of middle part, product or cosine of opposite part. Okay, so because they're opposite here, so I'm using the first formula here. Okay, first formula, sine of middle part. So if I write down, what does it look like? Okay, let's try to write down here. So I have sine of middle part here, sine. Okay, R is below the circle, right? Below lower part of the circle. So I should plot sine com R. Okay, sine com r, because it's at the lower part, you have used com here, equal to cosine, product cosine, opposite, right? So I'm saying cosine. Which one is below a p, right? So you can com p here. Because p is below the circle, then cosine of r, 60 degree. Okay, so I'm using the first rule. Okay, using the first rule here, sine of the com r equal to product of cosine. Okay, product of cosine of the opposite. Opposite of r is sine r and p. So let me copy this to the next line, then we continue, right? So I'm going to copy this thing to the next page here. And select page first. Okay, so I'm going to erase this triangle now and then do the calculation. Okay, so the calculation is this. Okay, I want to find out what is angle R here. So how to write now? Remember com here. So I will write there sine of com R means 90 minus R. Okay, com R means 90 minus R. Then cosine com P means 90 minus P. Okay, then cosine R. Okay, so basically I want to calculate this thing, right? So what is actually sine of 90 minus R and cosine of 90 minus P? How does it look like? Can you simplify it? Okay, we know cosine 90 is something like this, right? So I want to do a little bit of digression now. Okay, digression now, right? So we call about trigo now. Okay, trigo now. So trigo, okay, trigo. Right angle triangle. So that's right angle triangle, right? So this is actually A, B, C. Okay, so opposite, this is called opposite here. This is called adjacent. This is A here, and this is hypotenuse. Okay, if this is A here, this one is 90 minus A. B is 90 minus A, right? Okay, B is 90 minus A, right? So I want to find sine of 90 minus A. Okay, which is sine of B lah, huh? Okay, sine of 90 minus A, which is sine of B here. Where is sine of B here? Opposite of B over hypotenuse of B. Hypotenuse, right? Opposite over hypotenuse, all right? Opposite of B is adjacent. Okay, opposite of B is this part here, adjacent, right? Opposite of B is this one, adjacent. Okay, opposite of B is actually is adjacent here. Just write down adjacent of 2, right? Opposite of B is adjacent of A. Over hypotenuse. Adjacent A over hypotenuse, we have a name for this. We call it cosine of A. So next time you see sine of 90 minus A is cosine of A. Okay, next time you see sine of 90 minus A, you save a lot of shortcut for you. Sine of 90 minus A is same as cosine of A. How about cosine of 90 minus A? Can we do the same thing over there? Okay, cosine of 90 minus A is actually cosine of B, right? How to find is a cosine of B is opposite. Okay, where is opposite? Where is the cosine of B now? Is cosine of B of the one, the adjacent of B, right? So adjacent of B, hypotenuse here. Adjacent of B is actually opposite of A over hypotenuse, which is equal sine of A. Opposite of A over hypotenuse is sine of A. So at least you can save a lot of calculation. Sine of 90 minus A is cosine of A. Cosine of 90 minus A is actually sine of A here. Okay, so if you don't understand this, tomorrow I'll go through this again. Okay, so from here, and go back. So sine of 90 minus R, we found that, okay, this is cosine of R. Okay, go back again. Okay, sine of 90 minus A is cosine of R, A. So sine minus R cosine of R. Cosine of 90 minus P is sine of P. Then cosine of R. So I'm using this formula to simplify using right-angle triangle. Okay, so now put in a number. So this is sine 45 degree, cosine 60 degree. So you press the calculator now. Okay, sine 45 degree. So you get sine 45 degree times cosine 60 degree okay, this will become 0.3535. So what is R now? R equal to cosine inverse 0.3535. So you press the calculator, shift cosine inverse, shift cosine inverse, answer, and then you get 69.29. Which to convert the minute there is actually 69.18 now, about 69.18. So this is how you get the answer. Okay, this is how you get the answer. 69.189 R, and use R for the yellow one. So this is R here. So that means that this is actually, we find out that this is actually 69.29. Okay, so 69 degree, 80 minutes. There, I'll give you R already. Okay, lastly, I want to find out what now is side P. Okay, side P again. So I try to make this as my middle part now. Okay, side P as a middle part here. So let me copy this again. And go to the next page here. So now I'm going to use the second rule now. The second rule for this. So let me erase this one. So I find out R already. So now I try to make this unknown now. Okay, this make this unknown, make this a middle part now. The middle part is easier the one. So the middle part is actually this one now. So let me change the color now. So I'm going to change it to R here now. So I'm going to change the middle part now. P. Okay, P is the middle part here. And I don't need this one. So I use a different color now. So let me use a blue color now for adjacent now. This one. Okay, so I'm using the blue color one now. Okay, blue color one, let's write down the answer. So this time, I have assigned a middle part. Middle part is P now, right? But P is on top now, so you don't need any comp, okay? So this is the sine of middle part here. So sine of P, okay? Sine of the angle P here, the side P here, sorry, right? Sine of side P, okay? This is side P here, right? Okay, small letter. Okay, side P is equal to product of tangent. So tangent of 60 degree, because 60 degree on top there. Then tangent of com R now. Com R. Because R is below R, right? So it's com R here. So this is actually do calculation now. So sine P, the middle part here. P we don't know. Tangent 60 degree. And then tangent of com R. Com R means 90 minus R. Okay, com R means 90 minus R. So what is tangent of 90 minus R? We have a simple way to simplify it, right? We want to simplify it. How to simplify it? Okay, I'm going to use a triangle again. Okay, how to find tangent of com A. Okay, com A is 90 minus A, right? Okay, tangent of com A, we know this is tangent of B. Okay, from diagram, this is same as tangent of B here. What is tangent of B now? Is you take opposite of B over adjacent of B. Now, it's the opposite of B is tangent as adjacent of A now, and adjacent of B is opposite of A now. So this is actually 1 over this is actually 1 over opposite A over adjacent A. Okay, turn upside down. So this is 1 over tangent A. Okay, so this is another way you can simplify. Tangent minus 90 minus A is 1 over tangent A. Okay, so you can make use of that and come to a good calculation here. So this tangent 60, tangent 90 minus R is 1 over tangent R now, which is 1 over tangent 69/28. So our calculation. So you get tangent 60 first. Okay, tangent 60 divided by tangent 69.29 degree. And then you get 0.6548. So now what is P now? P is sine inverse now. The side P here is sine inverse 0.6548 here. So that's calculator. So sine inverse here. So shift, okay, inverse sine, the answer 40.90. You can convert the minute there. Okay, 40.54 minutes. And this is how you get answer for the first part. Okay, this again the yellow part again. Okay, so let me highlight to you. I have the yellow part here, and this is the blue part. And do the conversion. Okay, so I finished as promised. I finished example 1. Tomorrow I will try to in a class for you. There will be also another long example, right? So today I will stop here. Okay, so that will be all for today. Okay, so finish example 1 already. So tomorrow I continue, try to do another example for you. So I'll stop recording now.